this video, I want to look at the square roots of complex numbers. But before we can do that, we must first of all look at what happens if two complex numbers are equal. If I have the number a plus bi equal to the number c plus di, it would be very nice if a was equal to c and b was equal to d. In other words, the two real parts were equal and the two imaginary parts were equal. But we're dealing with complex numbers, and all sorts of surprising things might or might not happen. So if we start from that equation, we can rewrite it as a minus c is equal to di minus bi, that's d minus b times I. If we square both sides, we will get a minus c all squared is equal to d minus b all squared, I squared. That gives us a minus c all squared. I squared is minus 1, so that's minus of d minus b all squared. Well, a, b, c, and d are all real numbers. So we know that a minus c squared is the square of a real number, has to be greater than or equal to 0. And we also know that d minus b all squared has to be greater than or equal to 0. So minus of d minus b all squared has to be less than or equal to 0. Well, the only way that that can happen, if the two are equal, is if they are both equal to 0. If a minus c is 0 and d minus b is 0, in other words, a equals c and b equals d. So we have, as we thought would be nice, we have real parts are equal. Let's just tidy that up. And imaginary parts are equal. Okay, we are now in a position to go ahead and look at the square root of a complex number. So let's look at square roots of complex numbers. This is best done if I take an example. Let's suppose that we're asked to find the square root of let's make that just a bit nicer. 6 plus 8i. In other words, we're looking for a number a plus bi, which equals the square root of 6 plus 8i. Well, we start by squaring both sides. That will give me a plus bi squared is equal to 6 plus 8i. That is a squared plus b squared I squared, but I squared is minus 1, plus 2abi is equal to 6 plus 8i. Now we have two complex numbers which are equal. From what we've just done, the two real parts must be equal. So a squared minus b squared must be equal to 6. And the two imaginary parts must be equal. And so 2ab is equal to 8. That gives us that b is equal to 4 divided by a. Substitute that back in the first equation. b is 4 over a. So we have a squared minus 4 over a squared is 6. Multiplied through by a squared, we get a to the 4 minus 16 equals 6a a squared. Rearrange that, and we get that a to the 4 minus 6a squared minus 16 is 0. That gives us, it's a quadratic equation in a squared, so that will be a squared minus 8, a squared plus 2. Does that work? Minus 8a squared plus 2a squared, yes. And so this gives us that a squared equals 8, or a squared is minus 2, but a is real, so that can't happen. If a squared is equal to 8, then a is equal to square root of 8, which is 2 root 2, or minus 2 root 2, and b is equal to 4 divided by 2 root 2 is root 2, or minus root 2. And so the square root of 6 plus I, 8i, is 2 root 2 plus root 2i, or minus 2 root 2 minus root 2i. Now that is a very simple way to find the square root of any complex number. This is all done in your textbook FP1 on pages 21 to 23.